We welcome you here at the Technical Forum for the last day of the Group Exhibit Hydrogen and Fuel Cells 2013. Please have a seat, have a free drink here on the house. You are really invited to join with us the next presentation by BeBa H2 Speichersysteme, or in English, storage systems. And the title of the next topic is Renewable-Based Hydrogen Generation for Energy Storage Projects in Northern Germany. And your presenter is the Managing Director, Mr. Jörg Vock. Give him a big hand, please.
Yeah, good morning, everybody. It looks like it's almost nobody. After the Bavarian night last night, seems like people are not able to get up early. I'm pleased to present information about the projects that we're looking at for hydrogen storage in northern Germany. We're at BeBa working in the field of photovoltaic and wind plants, and we recently joined with a company that does PEM electrolyzers to be able to supply complete systems. Which one? That's quick. Brief overview about the BeBa company. The company is located north of Hamburg. Since 15 years operational in the field of wind and PV. It is able to do the complete engineering, installation, and also operation for wind and PV farms. We do several steps in complete projects. We do the site review first to begin with, feasibility review, if it makes sense to set up a plant at the site. We then do the viability studies to make sure that the economics are okay. Next step is to do the optimum system selection. Means we look at which type of PV systems can make most sense, and also the wind turbines. We give the customers the support during the necessary surveys to get the approvals. We actually help them to produce the necessary paperwork to come up with the approval documents, and we also support to make sure that the grid connection is established early on. Basically, this describes what has been done up to this point, so we call it the historical route. Once a wind farm and a PV farm is established and installed in operation, we feed to the electrical grid. Now, in times of more and more excess capacity coming up, we need to be changing the thinking, and new energy management systems are necessary. So we can go, instead of directly to the grid, we go to electrolysis, storage, and then we have different applications, fuel cells, gas engine, or hydrogen mobility. There's also another route which can be taken from electrolysis to storage, and in combination with a biogas plant, do what is well known and has been shown in other articles, do the methanization, which then can be fed to the natural gas grid or back to the same different applications. Now, the question is why we should go to storage, and why should we go to hydrogen storage, hydrogen being a chemical storage medium and actually an energy carrier. What I'm showing here is a table out of a presentation of Professor Stolten from Research Center Jülich, and you can see, unfortunately it's in German, that the options for mass storage, and we're talking mass storage to really get the excess capacity out of the way, The possibilities are best in the area of chemical storage, where we have hydrogen, methane, or gasoline, the traditional gasoline. And if you go through all the calculations and look at different production methods, there is, of course, different efficiencies in the different processes. But the most important thing you see here, when we talk about storage time, the hydrogen is really in the range of months and not just seconds like batteries or minutes for pressurized air storage. So that's the most important thing. We're capable of really taking the hydrogen that is being produced and store it for seasonal long periods to be shifted. That is the key and the driving force behind the systems that we should go for chemical storage. The advantages of the wind or PV hydrogen or storage as a hydrogen medium, as just mentioned, the long-term storage, and the hydrogen can serve as an energy carrier. We have various use of the generated hydrogen. It can be used as an energy source, but it can also be used as a direct medium in production, like in a refinery, for example. If we talk about, or for the metal industry, where it's used for heat treatment, etc. And of course, as an energy medium, it can be used in fuel cells to repower, to go back to the grid, or to fulfill local needs in electricity. What we also should be aware of and look at is the fact that we can have synergy effects. If we have existing wind and PV farms, we should look at also what is existing regarding transportation for the means for the hydrogen. So if we combine that and site the installations at the right place, we can combine the wind PV farms, and we can also combine the transportation like rail, road, or even boat up on the west coast. Here's a few examples that BeBa has done already. PV roof installations, also land-based, or combinations PV and wind. So we're capable of doing everything, and we did large, in the megawatt scale, large installations. Talking about storage, of course, if you have a small amount of hydrogen to be stored, you can go to cylinders, tanks, but this is really not enough if we talk about the megawatts that we have excess capacity from wind and PV farms. What we then need to do is go, for example, where it is possible, and especially up north it is possible, we should go to salt caverns. That means we should go pump the hydrogen that is being produced above ground, pump it into salt caverns where it can stay for long times, especially seasonal times. When there is a lot of wind, these caverns can be filled, and when there is low wind or PV conditions, they can withdraw the hydrogen and go to gas turbine, hydrogen gas turbine plants, and generate electricity in times of need. That's an overview of the potential applications when we generated the hydrogen via electrolysis, mobility, cars, boats, trucks. Boats especially is an issue that comes up in 2015, where the fuel, the existing fuel now for boats must be reduced in sulfur content. So there's a big challenge to do that. So it could be a good use for the large sea vessels that are around here. It can be used in food industry, like hardening of fats, margarine production. They use really lots of hydrogen in that area. Certainly analyticals and the pharmaceuticals industry, again as a raw product, the hydrogen can be used, and in these applications they need high purity hydrogen, which we can do with the PEM electrolysis that we're applying. In general, we can go to a green industrial environment, means we can take the raw material from the environment, generate the hydrogen and electricity, and thus generate a green industry. And then we can go back, of course, and generate power again. I want to show you a few applications in hydrogen that we already did. So how can the hydrogen be used? It can be used for mobility, as just shown. This is one example of a hydrogen fueling station that we did in southern Germany, in Freiburg. So you see a PV roof where we generate the electricity. Electricity goes to the electrolysis station, and then hydrogen is compressed and can be used for fueling of cars. In this case, it's two Daimler cars and also buses. Another application is blending of hydrogen into the natural gas grid. That's being discussed. There are some issues about this. Does it make sense? Is it critical? Is it accepted regarding the regulations of 2 or 5% maximum hydrogen in the natural gas? That's items that need to be discussed, but it has been proven, it has been tested, it can be done. The materials of constructions are there. The end users, like residential areas, they are happy. They can use the hydrogen directly that comes out of the natural gas grid. Another application is power generation UPS system, like remote or decentralized systems. So we can put a fuel cell, a UPS system in a container, place it somewhere, hydrogen to it, and make electricity again. This is something we've done in the southern European area on the island of Madeira. It's a first step to get the green island there. They want to replace about 6 megawatt of diesel power generation plants by wind and PV. Of course, they use directly the wind and PV if possible, but at night, they also have to store the hydrogen that can be generated out of the wind. And then at night, for example, they use it for street lights. So that's practical applications that already exist, and we've proven it's possible. What we use is the Hogan PEM electrolyzers made by Proton on site. This is technology that is very reliable and has been used in submarines and it can be used for the industrial and also the energy storage applications. More than 1,600 systems have been worldwide installed since 1996, so there's a long-standing experience with this new technology, but already proven. The application where we are in is important that we have electrolyzers to use the fluctuating power source from wind and PV. The plants must be able to run up and down quickly, because wind goes up and down, it fluctuates. The PV is also not going constantly when you have clouds covering. Then that means the power to the electrolyzer is fluctuating rapidly, and this is the advantage with this technology that we're using, the PEM electrolysis. We have a good gas that comes out of, and we don't care about these fluctuations. Here's an example of curves that have been drawn, how quickly the reaction to the power output or the electrolysis reaction is when the power input is fluctuating. You're talking about milliseconds of reacting time from a signal, means less power input when a cloud covers the PV panel, to the reaction of the electrolyzer. To summarize, if we want to do the energy storage via hydrogen, the PEM electrolysis is certainly best suited. Then, because it's safe, simple, clean, and reliable. Safe means we don't have to deal with any explosion issues. Simple means there's no operators needed to run the plant. Clean, we don't have any chemicals that are used like in other processes, in alkaline processes. We don't have to deal with these chemicals, neither by handling them nor by having them in the final gas, which then could be an issue in the downstream use. Reliable means these plants run for 10 years and they just need one annual maintenance tour, which is only a few hours, and even that maintenance can be done by the operator, by the client. The plants are flexible, as just pointed out. They are not only flexible that they react fast, but they can also go down to zero. So when there's full cloud cover, the plant goes down to zero production. It doesn't care. It comes back immediately when the sun comes back or when the wind comes back. So that's an important, very important point of the PEM electrolysis technology, the 100% downturn within a short period of time. What is needed? Water. That's all. And the electricity that we have from renewable sources. And with this technology, the result is very high purity hydrogen that can be used in any places. And that's the result of the presentation. Thank you.
Thank you very much, Mr. Vock, for this interesting and informative presentation. So, you here in the audience, are here any questions, or did you like to make any remark?
Hello, thank you for your presentation. This is Samuel. I have a couple of questions. For water, does water need a special treatment before the electrolysis process?
Yes, it does need treatment. It must be deionized. That is a simple step, and equipment for this is widely available worldwide.
Is also
many
embedded in the system of the electrolysis, or you have to buy it alone?
You can have both. It can be integrated or it can be separate.
Okay, for a global point of view, what is the impact of this technology on the water sources?
There's no impact I can see. You need very little water to make hydrogen. Basically 1 liter to produce 1 cubic meter of hydrogen.
Okay.
So it's very few water.
Thank you very much.
Mm-hmm.
Hello, thank you for the nice presentation. Here's Terrero from EMBW. My question is, can you compare the energy density of hydrogen with natural gas in terms of storage capacity?
That is probably best shown. Doesn't go back. Anyway, that was on the table I have shown that was created by Professor Stolten. You can Google that in the internet, Professor Stolten and Research Center Jülich. And there you see the whole presentation. He's showing the... Is it open again? No. He's showing the comparisons, energy density and cost and efficiencies and also the storage time. That was on that table.
Maybe you can summarize it with a few...
I don't have it on
okay.
right top of my head. Okay. I'm sorry.
Thank you.
We are still trying to get the presentation on the flat screen again.
Oh, okay.
Yes, now it works.
The energy density is here, and the question was hydrogen compared to natural gas. So the energy density is 1 on hydrogen and 3.6 on natural gas. So it's much higher, that's no question about it. But on the other hand, if you want to make the comparisons, methane is a natural resource also, but it will be used up at one point. And if you go via renewable source to hydrogen, then it's kind of everlasting. Yes, you certainly have to look at this. You have to look at efficiencies of the cycles to produce. That is clear.
No, thank you very much. Ich denke also, ich spreche besser Deutsch. Kann man also eine kombinierte Anlage machen, also mit Wind, Wasserstoff und Solarenergie? Wir brauchen A, ein Solarkraftwerk, B, Meerwasserentsalzung und dann können wir Speicher für die Elektrizität, auch für diese Länder, für Ägypten und arabischen Länder, bevor also die Desertec ist noch nicht intakt. Danke Ihnen.
Okay. I will repeat in English. The question is whether the hydrogen or energy can be stored from wind, combined wind and solar plants, and they store the energy that is made out of this and the water coming out of water desalination plants. Yes, it is possible. The question is, in certain countries, you don't have the possibility to do the salt cavern storage, so then you need to look for other possibilities. But in principle, you can use any source to go to the hydrogen generation and then store that. And the water can come out of water desalination plant, yes.
Die Kapazität, also die Capacity, also hier, we need, as example, also 350 megawatt hour.
Okay.
For Mecca and Medina, also for Saudi Arabia. Can we get this?
Yeah, the question is if there is large plants available or large storage capacity possible. Yes, it is possible. It's just a matter of volume, how to store it. And then certainly first step must be to generate it. If you look at the generation capacity of electrolyzers these days, there are alkaline systems that have been in operation during Second World War already. There were 500 megawatt scale. They are not existing at this point, but are being developed in a new fashion these days so that we get into that area again. And then you need the necessary storage to get to the terawatt hour or megawatt hour range. Yeah.
We can also a very simple example also for Wasserstoff, also for hydrogen, from rest of materials from agrar, that is very cheap. Can we get this? We have as example also the Hydra. Hydra is a boat. We can produce also here also hydrogen and to storage. How can we storage all the capacity till?
I don't know the possibilities that you have in the Middle East, Egypt, Saudi Arabia area. I don't know. I'm sorry for that. We have concentrated for northern Germany so far, but we can discuss. I can give you contact.
So, are here any questions left in the audience? No, not yet. So, you are here at the group exhibit,
yes.
Hydrogen and Fuel Cells. So,
yes.
Where's your booth? Can you just tell the audience maybe you wanted to discuss it more detailed or personally the topics?
Yeah, we are located in booth C71. It's in that direction. You see the Proton logo behind that.
Okay, thank you.
Good.
Thank you, Mr. Vock, again for being here and this presentation. Have a nice last day here at the group exhibit Hydrogen and Fuel Cells.
Good. Thank you very much for listening also.
So after a short break, we will continue our program with a presentation by ITM Power. Thank you for staying here.